Welcome to the Yvertud mine site. You can see here the Yvertud mine site, the pit environment, which is 250 metre radius, 60 metres deep. They've mined cryolite, which is a white rock like this. It was 3.8 million tonnes of actual cryolite was shipped out of here, mainly to US and Denmark. There's still cryolite remaining within the pit environment. Below the actual cryolite body, we've got a zinc siderite body, and further down there's quartz body of 5.8 million tonnes, which we're interested in. It's high purity quartz. The actual granite gryzon on the side of the actual pit is more interesting for rare earths. We've got sample assays showing the potential for heavy rare earths within the actual granite gryzon on the surrounding of the actual pit environment. There's the cryolite, there's zinc siderite, silver, galena, and zinc siderite, cryolite. So as you can see, the mineralization is all crystallized. It's in an amazing way. It's quite a unique. As you can see, there's galena, lead, and also which contains silver in the actual rock in this particular sample that we see. The mine was shut down in 1987, so this vehicle is probably here prior to that, and that was the workshop, and conducting most of the repairs on the vehicles were done in here, and there's an antique truck still there. The economic potential of this particular project is quite substantial. We do have the siderite and a 5.8 million tonnes of quartz body still remaining. There's cryolite, remnants of cryolite still within the pit environment. Overall, we have the power station further up, we have the housing, which we got access to. So overall, the infrastructure is here, the mineralization is here. There's the potential of billions and billions of dollars worth of rare minerals available. And it's well known scientifically and academically that there is very unusual geology within this environment. We do have the academics doing further research. They're on site at the moment. And overall, there is, from Eclipse's perspective, what we hope to delineate more an understanding of the outside rim of this actual pit, which is the actual granite gryzon, which is the surrounding of the actual pit, where how the actual mineralization has occurred. It's interesting for us to understand what are the other rare minerals and rare earths potential in the actual rim of this actual pit. So we're hoping to drill on the side to get better understanding of what further potential could be there. We're at Yvertud Power Station, and this is the actual generators that were providing the power supply to the whole mine site and the town. And most of the equipment is in very good condition, as you can see. It can be brought to life very, very quickly. Several $1 million worth of value that can be utilised towards rejuvenating this particular project. This is the sorting facility utilised back in the 1940s and 50s. As you can see, where they would put the actual the ore would come down there, and further down it would get crushed, and through the heavy duty motors there and put on the belt to be shipped out. Yeah, so this is where they actually would load up the cargo from here, from this area. You can see some of the remnants still standing here. Further down is the fuel tank and the power station on this particular place. It's got a lot of history, 130 years of production, primarily taking cryolite, which is the white rocks. And as you can see, most of the siderite is still left. They never focused on the zinc and siderite. These remnants are still got value. We've bulk samples, we've got that assayed, and it's showing value still remaining in some of these remnants, the waste dumps. Eclipse is fortunate to have Henrik Frisk and Adrian Finch as professors that really understand this environment, the Ivitud environment, and help us, assist us to better understand the geology. And I'd get Adrian and Henrik to elaborate on the geology and the relationship, how they could further assist our knowledge in understanding this environment.
So I guess the best way to describe it is you've probably seen CSI Miami. Well, this is CSI mid-Proterozoic back in geological timeframes. So in the CSI series, the people come in, they find a crime scene and they try to reconstruct all the events that must have happened to produce that particular crime. And we're doing a very similar thing here by looking and studying the rocks, working out which sequence of events came, and therefore in that we can work out precisely how the ore deposit that's here was formed and precisely when in time it was formed. And from this we can generate a three-dimensional picture of what the ore body's shape must be, and it gives us some clues as to what happens at depth, and it provides us with a mechanism by which the ore deposit must have performed, which allows us to understand and predict its appearance in other parts of the world.
Sometimes we get the whole science thing can be a bit slow, but that's why we keep coming back again and again, because every time we bring samples home, we analyze them, we learn something new, but we also get new questions. So we keep returning, and every time we get new knowledge, both about the formation and, as Adrian said, there can be transferred to similar deposits around the world.
All right, so what you see here is a tailing dam. It's a fairly large area. It's about 3 meters thick as we go down. We've trenched, sampled. There's a trench there, another one there, another one there, another one behind there. So we've taken representative samples from all of this. In total, we've taken about 80 tons. We've taken it to Qaqortoq, crashed it down to 30 mil, and taken a representative sample from that in a laboratory at the moment, pending final results.
Hi, I'm Curtis Rooks and I'm a PhD student at the University of St Andrews. And I was just telling the guys here that cryolite, this white mineral here, which was the main mineral that they used to mine for at Ivitud, if you get a very fresh piece of this mineral and you put it in water, it actually disappears because it's got the exact same refractive index as water, so it goes invisible. So the cryolite, cryo as in ice, it's ice stone, and it's like ice in water. So yeah, a little magic trick you can do if you find a fresh piece. So.
Behind that mountain here, you have the Gronnedal complex, which is a combined syenitic and carbonatitic structure, but it's also got a similar type of rocks like here in Ivitud, but older. That part is very much like the Ilimassar intrusion that hosts the Cranefjellet and the Tandbridge deposits. So up there you also have a very good potential for rare earth mineralization, and that's also something we are looking at.
My name is Malik Rasmussen. We provide all the services for Eclipse. We're here at the Ivitud Gronnedal area with all the rare earth deposits and the great mineralizations. So we are expert at providing all the services they need and help them with drilling and all the logistics, providing ships and everything.
You got carbonate. In here,
Yeah.
you got high-grade magnetite.
Yeah, yeah,
It's very magnetic, and then you got carbonate. Nothing.
yeah.
Very low magnetic. So this mixture is very unusual, and that's where the rare earth gets trapped as it's formed in the iron. So this if we were to go and assay this, I'm pretty certain this will give us very high grades of rare earths. Go for it. But we don't want to, this is not really, I mean, for market purpose, yes, but for us to understand the project, the one rock is not good enough. We need to have a representative sample, and this is all weathered. We don't know if that came from there, where it came from.